Alrighty, making a quick video or two to help out with graphing inequality practice, getting ready for our test here for the end of the unit. There's some nice reminders up here at the top. Using less than or greater than, we're going to use a dotted line, and less than or equal to or greater than or equal to a solid line. And some great reminders. This would be awesome to put on an index card. Plug in 0, 0. If it makes it true, shade the side with the 0, 0. If it's not true, shade the other side. So great little idea there. I'm going to do a couple of these here. I'm going to do the first two, but I'm going to fold my paper so you can focus in a little bit better, and I can zoom up a little here. So we're starting with graphing, and I stop and look at my inequality. That's going to tell me I need a dashed line. So I'm just remembering that. So when I'm ready to graph, I will make sure it's dashed. Now this one's in y equals mx plus b form. And you may remember that from your past algebra classes, that this is our y-intercept. So this is our fastest way to graph a straight line, and it works really nicely. So I'm going to put my first point here on my y-axis at -5, because that's a negative number. And then from there, this is telling me my slope is going to rise to run 1. So we're thinking about rise over run here. So from this point, I'm going to count up 2 and over 1, up 2 and over 1, up 2 and over 1. Now, of course, I only need 2 of those points to graph a line, but it's nice to have a couple more so I can make sure I'm being nice and accurate. And I could also grab like a straight edge, but I need to do a dashed line. So I'm going to remind myself of that, and I'm going to dash this line in. So we have a line that looks like that. And now my next task is to decide which part to shade. So here's that reminder. Plug in 0, 0 into our original equation, and we'll see if this makes it true or false. So I need to know, is 0 greater than 2 times 0 minus 5? I'm going to put a question mark next to that because I'm not sure. And I think, okay, is 0 greater than, let's see, 2 times 0 is 0, so -5, and I'm still not sure about that. Okay, so I need to now stop and think. Is 0 greater than -5? And I'm going to say, yes, it is, because 0 is here, and -5 is here. 0 is higher up on the number line. So 0, 0 is a point that makes this equation true. So I'm going to shade everything on the side that includes 0, 0. So that's how we would work through that one. Now this is nice because the y, it was already in mx plus b form. So I'm going to do another one just like that, and the one just below it. Same kind of thing, y equals mx plus b. Let's graph it. Y-intercept at -4. I'm going to rise 5 and run 2. So don't let fractions slow you down. It already gives us the rise over the run. So 1, 2, 3, 4, 5, run 2. 1, 2, 3, 4, 5, run 2. And to connect these ones, I'm also going to use a dashed line. This line looks a lot like the one above it, but it's slightly different. Looks like it's a little more upright. And I need to know, is 0 greater than 5 over 2 times 0 minus 4? Is 0 greater than, let's see, this is going to be 0. Is 0 greater than -4? And I'm going to say yes, it is. It's higher up the number line than -4 is, so it has to be greater. That means this is all part of our solution set. I could take any point within there and it would make that statement true. keep on trying a couple more like that. I'm going to flip my page over and do a couple that are in the other format, what we call standard form, where they have x's and y's on the same side. Now this is a little bit, few more steps for us to graph, but still the same, same kind of idea. This is the one where I think, okay, I need 2 points. So for my first point, I'm going to say x equals 0, and I'm going to solve for y. So 3 times 0 plus 4y less than or equal to 12. 3 times 0 is 0, so I'm not even going to write it. 4y less than or equal to 12. Divide both sides by 4. And y is less than or equal to 3. So I found my x-intercept, or sorry, no, this is my y-intercept. X is 0, so I'm going to stay right at the origin. I'm going to go up 3, 1, 2, 3. I'm going to put a point there. And now for my second point, this time I'm going to make y equal 0. So 3x, I'm honestly not even going to write the 4 times 0 because I already know that's going to turn into a 0, so I can just kind of ignore that. I'm going to even use my pencil to cover it up. And I'm thinking 3 times x is less than or equal to 12. Divide both sides by 3. And x is less than or equal to 4. Hey, all right. Put in 0 for y. This means I'm not going up and down on my graph at all. I'm just going to go over to a positive 4. I need to connect these, but I need to check what kind of line first. It is less than or equal to, so I'm going to use a solid line to connect our 2 points here. So it's going to look something about like that. Nice solid line, clearly solid line. We try to make it as clear as we can. And now, last but not least, I need to check 0, 0. So let's plug them both in. 3 times 0 is 0, plus 4 times 0, which is 0, and I need to know if that's less than or equal to 12. Well, 0 is definitely less than 12, so I'm going to say yes, and that means this side here that includes 0, 0 is the part that I'm going to shade. So wherever 0, 0 is in relation to the line, that's where the shading is happening. Let's do another one like that, right below it. I'm going to move a little bit faster. I'm going to say x equals 0. I'm not even going to write that first term because 2 times 0 is 0. So we have 5y greater than 10. Divide both sides by 5. Y greater than 2. I have a point at 0, 2. 0, 2. Second point, y equals 0. I'm going to ignore this term right here, so I'm just going to cover it up. 2x greater than 10. Divide by 2, divide by 2. X is greater than 5. 1, 2, 3, 4, 5. I've got 2 points. I'm going to connect them with a dashed line. And I'm going to see now, I'm going to check my point at 0, 0 to see if I'm shading below the line or not. 2 times 0 is 0, plus 5 times 0 is 0. Is 0 greater than 10? No. 0 is less than 10. So this time I'm not going to include that point in there. That is not a solution. So that means everything on the other side has to be a solution. So everything we shade in here is a solution to this system. All right, so there's 4 great examples for you with our y equals mx plus b form. and our standard form. Keep on going. There's some more on the back that are working with some negatives, but the same kind of thing we're going to do every single step.